Hey folks, Quilly here, and welcome to another episode of our C# tutorial for complete beginners. In the last episode, we introduced the concept of variables, and we learned a couple of pieces of vocabulary belonging to the console library of functions. We've learned console.writeLine and console.readLine over here. Now, it's worth noting again, I'm going to repeat this quite often as we go forward, is that there's learning the language, syntax, and grammar, and there's learning the language vocabulary. This console stuff you won't use if you're working in Unity, for example, because Unity has its own library of vocabulary. You're going to be using things to tell Unity to, display models and textures and stuff on screen, which is very different from console.writeLine. But that's okay, because everything you learn about the actual syntax of grammar of C# in here is going to be useful all over the place. And that's why I'm going to keep the vocabulary learning to a very, very minimalistic thing. So, we learned a few basics here, but let's make our very first game. And what we're going to do is we're going to create a game that is a very, very standard example of like beginner's programming. We're going to make a number guessing game over here. So first thing I want to do is I actually want to go and clear this all out. All right, so go ahead and delete everything over to here. So this is just our main function that is now empty. So if we were to run this program, it would immediately exit because there's literally nothing it would do. It would start and stop immediately. So what we're going to do is we're going to say console.writeLine, and we're going to say, let's play a number guessing game. Console.writeLine. So we open the parentheses because this is a function and it needs a parameter. In this case, we're going to pass it a string. So we start with the string. We say, I'm thinking of a number between 1 and 10. Console.writeLine. What is your guess? There we go. So we're gonna start it off by saying this. Play a number guessing game, thinking of a number between 1 and 10. What is your guess? And then we're gonna ask the user for his guess, his or her guess. And we know that we can use console.readLine to ask the user, to allow the user to type in something, and this will be returned as a string. So whatever the user wrote is going to be returned here. So we can confirm this by saying console.writeLine, you guessed, and then we're going to use the plus symbol, which here means concatenating strings. You guessed this. So let's run this and make sure that goes okay. So we're going to run it. Let's play a number guessing game, thinking of a number between 1 and 10. What is your guess? My guess is 6. You guess 6, and then the program ends. Okay, great. So a couple of things we need to do here. How do we get the computer to think of a number between 1 and 10? Well, I mean, we could just literally right now, I could roll a die and pick one. We can say, oh, the computer's thinking of 4 every time. Let's actually start with that. So first of all, I'm going to say, so the string, we're going to create a new variable. It's going to be a string for now. It won't be later. And we're going to call this one answer. The answer is 4. This is what the computer is thinking. So the answer is supposed to be 4. The user's guess is here. So you guessed this. How do we tell if the user is correct? Well, we use the if statement. So if allows us to test something. It's not actually a function, okay? But you might be able to imagine it sort of a little like a function, because if in C# has parentheses, and in here, this is the condition that's going to be tested. If whatever is inside these parentheses evaluates to true, if will then execute the following block. Okay? These curly braces, which we've seen over here, define blocks. And an if statement does the following. If whatever's in here is true, this happens. So let's say, what if the user is correct? How do we confirm that? Well, if the user's guess is equal to the user's answer, or to our answer, then we are clearly correct. We're going to talk about this double equal sign in just a second. So let's go first, console.writeLine, and say, you are correct. And let's just test this to confirm that this works, okay? So what is your guess? My guess is 4. You are correct. Let's try this again. What is your guess? My guess is 5. You guessed 5. No, you are correct. So this is clearly working. So what's the deal with this double equal sign? Well, here's the thing. Because you would normally assume this, right? If guess is equal to answer, then it must work, right? Well, the problem is that this single equal sign is the assignment operator in almost every single programming language. A single equal sign is the assignment. It takes whatever's on the right and assigns it to the left. This is setting the variable guess to the value of answer. So if answer equals 4, that means, let's say I guessed 10 and we get to here. What this is actually trying to do is take the number 4 and stuff it into my guess, which is obviously not what we're trying to do here. We instead want to compare the two. And that's what the double equal sign is. It's the comparison operator. I think that's the right term for it in C#. I might be wrong. But it compares these two. It checks to see if the value of guess is equal to the value of answer. And if so, it returns true. So if these two things are the same, this entire expression evaluates to true, which means the statement in here, the expression in here evaluates to true, which means if will then execute this block. If guess and answer do not evaluate to the same value, then the double equal sign here returns false. So then the if block does not get executed. Very important. Luckily, it's mostly impossible to accidentally do the wrong thing here, because you can see this would actually generate an error, and there's all kinds of reasons for it, but ultimately it's because this needs to be a Boolean that it evaluates true or false, and this with a single equal sign, there's no evaluation. Doesn't result in true or false. It actually, the assignment sort of as a side effect returns the assignment itself, but listen, let's not get into that. Double equal sign, you need it. Learn it, love it. That's the reason I actually say in these, I always say is equal to, right? I don't say if guess equals answer. I don't say that because when I do that, I might by default do a single one. Because I always say very explicitly if guess is equal to, because I have extra words in there, it helps me remember to put in the double equal sign. So there you go. All right. So we check that. All right, so we say something if the user is right. How do we say something if they are wrong? Two ways we could go about this. First, what we could do is, okay, if guess is equal to answer, we say you are correct. We could then instead say if guess is not equal to answer. If it's not equal to answer, then we can say console.writeLine incorrect. So then let's try to run that, confirm. What's my guess? I'm going to guess 8. Incorrect. Okay, so that's one way, by saying not equal. The other thing you can do is the else statement. An else, so an if followed by an else. The else will only execute if the if is false. So if this is true, this happens. Else, this happens. So this will also work. So if I guess 4, I'm correct. If I guess 8, I'm incorrect. If else. Very good. There'll also be sort of an if-else block. So in addition to if and else, there's also if-else. And we'll look at that probably a little bit later. Actually, very, very soon. So we've got that. That's great. Wouldn't it be fun if instead of saying you're right, or rather, you're right and then exiting is probably okay. But instead of saying you're wrong and then just exiting, what if we give the user a chance to guess again? So we are going to introduce a loop in here. We are going to loop until the user guesses correctly. So we're going to make a bit of a change here. So when you're incorrect, we're going to say try again. And what we want to do is we want to allow the user to guess again. So we're not going to just type that again down here. We're going to wrap this whole thing in a loop. We're going to use a while loop. So a while loop is a little bit similar in structure to the if statement. You get while, and then you get a parentheses, and then you define a block. Take all this, just hit tab to move it over. Keeps things nice and organized. A while loop is very simple. While the expression in here is true, then we repeat this block. So technically a do while would probably be a little bit better here, but that's okay. So while the expression in here is true, we keep repeating this block. So what can we do about that? Well, let's literally, for the sake of argument, I'm going to start by putting the word true in here. True and false are keywords that are just those booleans, those values. This is just the value of true. So this will loop forever. We can check that. If I run this, what is your guess? I guess 6. I'm incorrect. Try again. 7, 8, 3. Is it 4? Ah, 4 is correct. Although we're still looping forever. So we can X out of this window. That should work out just fine. So, okay, we've got that. How do we break out of this loop? Well, there's a couple of different ways to do it. One thing you can do, if you're inside of a loop and you say something like this, you can actually use the word break. Break out of the loop. This will basically backtrack through your code until it finds the first loop that we're in this case this while statement, and it just ends it. So if we try this, so if we guess 6, no, we're wrong, it's still looping. If we guess 4, you are correct, and it breaks the loop. So that's one way of doing it. Another way is this value in here, if we change the evaluations. Let's say this, let's make a new variable, a Boolean variable. User guessed right. It's going to start by being worth false. So while, user hasn't won. Let's do that. The user hasn't won yet. So while the user hasn't won, we're going to loop here. And instead of breaking the loop, we're going to set user hasn't won to be equal to false. Right? So now, what's going to happen is we're going to write you're correct. We're set user hasn't won to be equal to false because he has won. And then we're going to evaluate this again, and it's going to exit us. My guess is 4. You're correct, and it ends the loop. That's not particularly the nicest way to do it, but it is a fine way of doing it. Probably a better way is instead of using a while loop, we use a do while loop, which needs a semicolon at the end and slightly different value over here. Let's just set it to true for a second here. So the difference between a while loop and a do while loop is a do while will always execute this once. So it will run this code at least once, and then only repeat again if while is true. So for example, we only want to loop again if the guess is not equal to the answer. If guess is not equal to the answer, then we're going to go again. Let's try this. So now we don't need any logic in here to break out of the loop. It's just that we only loop if the answer is not correct. You see we're getting an error here. And in fact, if we compile it, what's going on? The name guess does not exist in the current context. What's going on? The compiler is saying it doesn't know what guess is. You're like, well, guess is a variable. We define it over here. Scoping. Variables have scope. They only exist in their current block. So here we define guess inside of this loop, which means guess only exists inside of this loop. It does not exist outside of the loop at all. And in fact, you can have the, for various values of this, never do this because it's a bad idea, you can have variables with the same name inside of the same set of code as long as they're sort of within different blocks. So guess only exists here. So by the time we get out over here and we check to see our loop condition, it no longer exists. So what we need to do is we have to move our definition of guess outside of our loop. And then do this. So we set guess inside of our loop. That's fine. As long as it's defined outside, then it's all the same guess. And if we compile now, everything is okay. We'll run this. What is my guess? It's 6, 7, 8, 3, 4. 4 is correct. So as soon as guess not equals answer stops being true, then we no longer loop anymore. Okay, so we get a little bit of control flow over here, a little bit of if statements. Not a particularly fun example, but we're getting to something. This is a game. It's got the ability to output stuff, input stuff, and tell the user if they've won or not. Let's get a little bit more information over here. And here we're gonna reveal a shortfall for our particular implementation. First of all, you notice we're not actually generating a random number yet. That's okay. We'll do that soon. What we want to do is instead of just saying that the user is wrong, we want to give the hint. We want to give the user a hint if the number I'm thinking of is bigger or smaller. So let's change this a little bit. So there's a couple of different ways we can structure this. Inside of this else, we can have another set of ifs, right? If something else something else. So if the user hasn't picked right, we could do another check in here to say, is our number bigger or smaller than what the user guessed? And we can let them know. Alternatively, we could replace this else block with, all right, so they're not correct. So we could say else if this, else if that. This is all part of the same sort of chain of events over here. But now instead of just saying else, just do this, we're going to say else, do this if this thing is true. And then we can compare if the answer, so we know that the guess isn't equal to the answer, but is the answer bigger than the guess? Ah, bigger. Ah, larger. Okay, yeah, good. You know that symbol. Then we can say something like console.writeLine. Incorrect. My number is larger than your guess. So let's do that. Let's just do this for now. But you'll notice, see that red underline? If I try to compile, operator greater than cannot be applied to operands of type string and string. What's it saying here? It's saying you're giving me two strings and asking me to compare which of the two strings is greater than the other. A string is just a series of characters. This is like, it's the same as if we said something like if apple larger or greater than orange. Oops. If apple greater than orange, do something. And the computer's like, I don't know how to compare these two. These are just strings. What? They're just words. If apple is bigger than fire truck. If apple is bigger than 123 3rd Street, New York. Like, how do you compare? Well, you can say, well, I meant length, or I meant this. Well, then you have to say, is this string's length larger than this string's length? I'm going to talk about that later on, maybe. I don't know. Now it's fine. Now, because length is an integer, and the greater than symbol works totally fine with integers. Is this number bigger than that number? Okay, we know how to deal with that. But what are we actually asking for over here? We don't want to compare the strings. We want to compare the numeric values, right? We want to compare the number 4 to the number that the user entered. And we're running into a deficiency here because we don't have numbers. The computer has no idea that 4 is a number as opposed to orange. Or it could even have numbers. Again, 123 3rd Street. There's numbers in there, but it's a string. So how do we actually get from point A to point B? Because this guessing game right now, it's not actually guessing numbers. It's more like, what string am I thinking of? So if we did this, then we'd have to type in the word orange to guess correctly. But we want a number guessing game, and right now we're a string guessing game. Okay, so that's fine. So let's do a little bit of change over here. We say, oh, we want numbers, right? So I'm going to change answer to an integer. Yes, integer, whole number. Now we get a complaint over here with the underlines because we're trying to stuff a string into an integer. So we're like, okay, so we get rid of the quotes. So now 4 is just a number. So now we put the number, the integer 4, inside of a variable that's designed to hold integers. That's great. Okay. But the problem is now we're still comparing over here the string guess against the integer answer. So that's still no good. So we have to make guess into an integer, I guess. And then if we hit build, this is no longer an error. The computer's perfectly happy to compare for equality or compare for greater or larger than, or greater or less than values. That's fine with integers. But now we've got a new error over here. Cannot implicitly convert type string to integer. Console.readLine returns a string, and we're trying to stuff it inside of a variable that's designed to hold an integer. The computer by itself does not know how to do that. Because again, your string can be anything. You're taking input from the command line that the user could write anything. They could just, a cat could walk across the keyboard. Or they could type in they could type 4, F-O-U-R. Well, that's not the same as the number 4. how do you get from a string to an integer? Well, in C#, integer, so we don't need to create more variables here, but for the sake of argument, what I'm going to do is I'm going to create a new integer here, or sorry, a new string, which is going to be the guess string. Okay, I'm going to make it very explicit here. This is the guess string. And you guessed this string. So now it's complaining because guess hasn't been assigned yet. That's okay. We can just ignore that for now. So this is the string that the user typed in. You guessed blank. We need to turn this string into an integer. So we can do that because the integer type over here actually, and depending on languages, sometimes these are like fully qualified classes and objects and things like that. We're not going to get into some of those details. But what's important is you can go int, .parse. Parse means we're going to take a string and we're going to try to read that string and build a number from it. So we are going to parse the guess string and stuff it into this integer. This is going to try to, because you and I can look at like a string like this and say, well, clearly that's supposed to represent the number 4. And that's what int parse is going to try to do over here. So, okay. We try to build this. Code is happy. There's no syntax errors anymore because we are going to read a string from the console, stuff it in here. Then we're going to parse that string and stuff what we parse into an integer variable. Then we're going to compare those two variables, and then we're going to, for equality, then we're going to compare them for whether it's larger, and I'm going to take this whole block, and is it less than, less than guess, then we're going to say my number is smaller than yours. Now, we don't actually need this bit, because the only possible thing, if they're not equal, and answer is not greater than guess, then really the only possibility remaining is that my number is smaller than your guess. So these two things are equivalent. Okay, so let's run this. What is your guess? My guess is 6. Incorrect. My number is smaller than yours. Oh, how about a 3? Oh, my number is larger than your guess. Okay. How about a 5? Smaller than yours. Oh, then I guess it must be 4. You are correct. Hey, we have a guessing game with feedback. There's still a bit of a problem here. What is your guess? My guess is 4. F-O-U-R. And then we get a crash. Why is that? Input string was not in correct format. At string to number, parse in. What's going on here? If you read it backwards, because this shows you where the error hit. Inside of this function, system.number.string to number, which was then called by system.number.parseInt32, which was itself called by system.int32.parse, which was itself called by C# tutorial main class main at line 22. It tells you exactly what file. Program.cs line 22. Program.cs line 22 is right here. The problem is int.parse literally doesn't know what to do with the letters F-O-U-R. And that's okay. That's by design. It's not supposed to. And it recognizes that the string you're putting in isn't valid. In fact, even something like 123 3rd Street will also give us an error. Even though there's technically, number characters in here, it's not a valid number. So it throws an error. And that's fantastic. You want your program, if something goes not quite right, you want your program to explode in the most violent way possible so you know something isn't quite right. Now, that's different in shipping code. Maybe in shipping code you want things to fail silently and for your program to try to do the right thing. But even then, that maybe works for games sometimes. But for, regular applications, if something goes wrong, you don't want to, go ahead with wrong data. You want to stop, let the user know that something's gone terribly wrong, and don't proceed any further. So, what do we do about this? Well, this is going to be a little advanced, and I don't really want to get into what this means exactly. But when int.parse fails when it gets an invalid string, what it does is it throws an exception. And that's the system for reporting errors in most modern languages, by throwing an exception. What we can do is we can check to see if this has happened. It's worth noting there is a different version of parse called try parse. It's got slightly different parameters. It needs an out parameter, and what it does is returns a Boolean. It tells you true or false if it was successful. You may want to look into that, but I much prefer, and I think it's much more robust, to instead just try this as is and wrap this with a try block. So this will try to execute the following code. And if that code throws an exception, we will catch that exception. So what we can do is we can do something with E over here. Why is it not happy? Oh, it's because we don't have a block over here. We can say, okay, something's gone wrong. We can say console.writeLine. That is not a number. There we go. And yeah, it's interesting. Use of because we assign it here. It's funny that it's a bit of an error. But I guess because it's possible for us to get here. So we're going to say that is not a number, and then we're going to just bail. We're just going to bail on the whole program. We're going to do that with return. We can explain why that is later on. There we go. Okay. This try catch thing, it's more than you should have to deal with at this point. This is advanced mojo. But this is how you deal with this. So let's give this a go. What is your guess? 5. Okay, that's fine. We tried to parse the character 5, and we got a number, the number 5, which is great. Now I'm gonna put in 1, 2, 3, 3rd Street. It's gonna try to parse this into an integer and fail. You guessed 1, 2, 3, 3rd Street. That is not a number. Press any key to continue. Return, we're gonna talk about this more, but what it does is it returns from the current function. Our current function is main. When you return out of main, the program is done. That is the end of the program. So we're getting a warning here that the variable E is declared but never used. When you catch, you actually don't have to specifically catch the exception. You could just do this. This will just generically catch any thrown exception, but ignore it. It'll sort of catch it and throw it away, but it'll still execute this code. Okay, so we print this out and then return it. But you can specifically catch the exception in a variable here. This is exception E. And I can print out the error message. Console.writeLine. The error was, and I can go plus E. I think this will work. Does it implicitly call toString? Apparently it does. So let's try this again. You guessed blah. That is not a number. The error was, and then we print out the information from the exception. It's not complicated, but I understand if this seems like way weird and bizarre right now. And I apologize for that, but when you do deal with this parse, if someone puts in something that's not a number, it will throw an exception, and you sort of have to know what that means. Anyway, we technically have a game here. It's not a very fun game. So next episode, we will try to make a more fun game. We're actually going to start over from scratch. Next episode, we're also going to introduce classes, which again is something that's like, wow. From someone who learned programming with BASIC and then like C and Pascal and all these things like way back in the day, when like object-oriented programming was like the new kid on the block. That was some newfangled nonsense for most people. It feels weird to have to introduce classes in object-oriented programming so soon, and yet the reality is most modern computer programming languages are very object-oriented because it's awesome and the best. So we are going to have to train you up on that. And that's okay. So next time we're going to make something that feels maybe a little bit more like a conventional game, and we're going to look at some cool new mechanics. Thanks for watching. See you next time. Thank you everyone who continues to make Project Porcupine a reality by supporting us on Patreon. You guys are supporting us through August and early September, and including these mic check supporters, we've got Drazion, Jan Torivel, Julian Auger Lafont, Craig Mortel, Neil Blakey Milner, Ole Peter Talgo, Wes Oldenbeving, Kale the Quick, Valiant Cake Fiend, Aaron Toiveson, Michael McClintock, Marius Fieldvold, Speedy Savant, Jason Yanity, Adjective, Steven Stager, Kupropanda, Yukofin, and absolutely everyone who's watched, shared, favorited, and subscribed these videos. I appreciate you very, very much.